the two lines L and M have equations. Show that perpendicular. So perpendicular means the dot product is 0. Since we are talking about lines, we have to use the line directions. So for the line directions, we use this guy, the one with the parameters, the one with the st or lambda mu. So 4 minus 1 3, that's the direction of line L, and minus 1 2 2, that is the direction of line M. So the dot product means we multiply the corresponding components, the x components, 4 times minus 1 times 2, 3 times 2. Okay, so x, y, z components we multiply and just use a calculator. We should get 0, which means they are perpendicular. And the next part, show that intersect and the intersection point. Okay, so let's say they intersect at a point called P. So the coordinates of P, or the position vector OP, would be, well, the point should satisfy both equations, the L and the M. Okay, so from here we have 3 2 5, 4 minus 1 3, and here we have 1 minus 1 minus 2, minus 1 2 2. So we have to find certain values of S and T such that we get exactly the same point of intersection. Okay, intersection means the point lies on both lines. So we make 3 equations from each component. From the x component we have 3 plus 4s on the left, and on the right we have 1 minus t. From the y component we have 2 minus s and minus 1 plus 2t on the right. So we can just use these 2 equations, substitute, eliminate to find the values of s and t. So here we are eliminating, we multiply the first equation by 2 here. So we get 6 8 2 minus 2, just like this. We multiply all the numbers by 2, and here because we have minus 2t plus 2t, we cancel out by adding, and we add, we get 8, we add, we get a minus 7, 8 minus 1 is 7, and 2 minus 1 is 1. And then from here we subtract 8 from both sides, divide both sides by 7, we get the s value. To find the t value, we can use one of the equations. If we use the first equation, we replace the s with minus 1, we can find the t. So this is minus 4, 3 minus 4 is minus 1, and then we subtract 1 from both sides, divide by minus 1, so the t is just 2. Okay, so we have the value of s and t, but now we need to plug into the third equation. So in the third equation we have 5 plus 3s equals minus 2 plus 2t. Okay, so the third equation we plug in. So this is the third equation. We plug in the s and the t value. Make sure you get exactly the same on both sides, which means they do intersect. And now we find the point of intersection by plugging in to the first or the second equation, and you will get exactly the same result whichever equation we use. So for example, 3 minus 4, that's minus 1, 2 plus 1, that's 3, 5 minus 3, that is 2. Okay, you can also use these equations. Okay, now show that the length of the perpendicular from the origin to the line L is, okay, so the line L, just start by drawing a random line to visualize things and label the line equation. So from O to from origin to the line, so origin is 0 0 0, so the perpendicular distance, so this is perpendicular, this perpendicular distance is supposed to be 1/3 root 5. So we're going to have to find the magnitude of the vector OQ and show that it is 1/3 root 5. So to do that, we use the fact that since they are perpendicular, this factor OQ dot the line direction is equal to 0 because dot product equals 0 if it's perpendicular. So to find the factor of Q, that'll be the coordinates of Q minus the coordinates of O. So it's just x, y, z basically. And to do the dot product, we multiply corresponding components, x times minus 1 and y times 2 and z times 2. Now we have an equation in 3 unknowns. We cannot solve this. That's why we use the fact that this point lies on this line, which means whenever we want, we can replace this x with 1 minus t, we can replace the y with minus 1 plus 2t, and the z with minus 2 plus 2t. So that's exactly what we're doing. We replace this x with 1 minus t, the y with minus 1 plus 2t, and the z with minus 2 plus 2t. Okay, now we have an equation in one unknown, one variable t. We can solve for t. Open up the brackets, open up the brackets, open up the brackets, and collect the like terms. 1, 4, 4, that's 9, and minus 1, minus 2, minus 4, that's minus 7, and add 7 to both sides, divide by 9, we get the t. So since we have the t, we can find the coordinates of Q by plugging in that t value. So just use your calculator. 1 minus 7 over 9, that's 2 over 9, minus 1 minus 7 over 9, that is, minus 1 plus 14 over 9, because 2 times 7 is 14. So minus 1 plus 14 over 9, and minus 2 plus 14 over 9. Okay, so you should get these values. To find the magnitude, we use this formula, the square root of the sum of the squares of the components. So 2 over 9, 5 over 9, minus 4 over 9, we square everything, we add, take the square root, and use the calculator, we get what we need to prove. Alright, I'll see you again.